Hello everyone. Today, myself Amit Mode and along with my fellow classmate Sahil Bhatia, group number 39, we are going to present our project which is implemented towards a fog-enabled efficient car parking architecture. So, now further we will see the slides. The automotive industry is like growing day by day and personal vehicles have become a significant transportation resource right now. So due to this rise, we are facing several issues like traffic congestion, waste of time, environmental pollution, and most necessarily the unnecessary use of fuel consumptions. So like for that, on the other hand, we also know that car parking spaces in the urban areas are not increasing at the same rate as the vehicles on the road. So therefore we need a smart parking system that became essential to address this issue. So now this architecture or this proposed project can also be implemented using cloud solutions, but there are several issues with that, and that issues are like higher response time, high latency, network usage issues, and more consumption of network bandwidth. So this is the reason why we will shift to the fog-based solution. So this is our proposed fog-based architecture where the cameras will take picture and send to the fog node in the tier 1 or the first layer. Then on the second layer, the fog nodes will process those pictures and identify the parking slots for our systems. And for the third tier, the fog nodes will connect to the cloud through a proxy server. And here we can see that the different these are like single and multiple parking areas. So in single parking area, the all the cameras will be connected to a fog node using a microcontroller, and that single fog node will connect to a proxy server, and through the proxy server it will connect to a cloud server. So this is the single parking area, whereas in multiple parking area we can see that we are having multiple parking lane 1 2 3 in such way, and that every camera will connect it to same microcontroller, and then that microcontroller will connect to a node. So here we will have multiple nodes, and all those multiple nodes will connect to a single proxy server, and that proxy server will connect to a cloud server. So this is the single and multiple parking areas architecture. Now my fellow mate Sahil will continue the slides.
So I will now tell about experimental setup. So what we did was that we simulated the proposed architecture using iFogSim, which is a toolkit for IoT device simulation. And we used two variables, number of parking areas and number of cameras. And we used three modules in this, which are picture snippet module, image encryption module, and slot detector module. Uh, in the proposed solution, there were only two modules, namely picture snippet module and slot detector module. But the author did not consider privacy and security aspect of the uh, this architecture, so he did not include any method for encryption. We included image encryption module in the camera so that when the image will be transmitted from cameras to the fog nodes, it will transmit in the encrypted form. So these are the topologies in the iFog sim. On the left one, it is the scenario where the cameras are directly connected to the router and to the cloud, straight away to the cloud. But on the right, we will be employing a fog layer between this to minimize the latency and network usage. So these are the parameters that we will be measuring. So latency is first is latency and second is network usage. So latency is the sum of tuple CPU execution delay, time to upload pictures on the fog node, and time taken to display the information on the LED. And network usage is basically the product of latency and the tuple network size. So uh, what we are essentially doing in this proposed architecture is that we are detecting the we are capturing the images from the cameras. We will be transmitting them to the fog node, which will process them, and then we will display the result on using the LED that will be placed outside each parking lane, from which the user can check whether that parking lane is empty or not. So what is our contribution in this is that as I told earlier, that proposed solution had only two modules and which did not ensure the privacy of the images. So we incorporated an image encryption module in which the images will be encrypted before being transmitted to the fog layer. And furthermore, we also computed our results based on all these three modules, and we compared the band latency and network usage in both fog and cloud-based architectures. So these are our simulation results that we carried out in iFogSim. So as you can see here, we have taken number of areas to be 4 and we have varied the number of cameras per area. And you can see here the fog latency and cloud latency, there is large amount of difference between these two latencies. Similarly, the network usage in fog architecture is quite less than that of cloud architecture. I would also like to point out that when we simulated our results, we created a file for simulating these architectures, and we found out that there was quite a lot difference in the results of the simulation. Although the fog latency and fog network usage were quite similar, but uh, we wrote our script in such a way that there was difference in the cloud network usage and cloud latency. Also, we added an third layer, a third module, which was image encryption module. So that also had difference in the final results. But we can infer from these results that the fog latency is quite less. Also, the fog network usage is quite less, and it is the difference between these two is quite huge. Also, if we compare the these results, so we will find out that as the number of cameras increase, the latency will increase in both these scenarios, but in cloud it increases to a large scale. On the other hand, it will also increase in fog layer, but it will not increase as much uh, as in the cloud layer. Similarly, in the network usage in both these architectures, so the cloud-based architecture uses lots of network, and while the fog-based architecture uses quite less amount of network. As you can see from this table, it is quite a small fraction of network that was in the cloud. So finally, to the conclusion, so we have found out that according to the experimental findings, the fog-based architecture has very less latency and very less network usage than that of the cloud-based architecture. However, there were some uh, limitations of the proposed architecture. Firstly, it did not consider privacy, and but that was taken care by our image encryption module. However, there is still a drawback that as the number of devices and number of cameras and number of areas will increase, we will need a proper load balancing on the fog nodes in order to retain the efficiency so that it can efficiently scale up as per the demands. So this was all from our side. Thank you.